Hi there everyone and welcome back to the channel. I'm really excited today because we are going to be looking at a brand new digital video transmission system from EDGE Smart Drives. This is the EDGE T3 VTX and VRX. This is available for $279 for the VTX and the VRX, and I think this represents a glimpse into the future of how we are going to be communicating with our FPV drones. Calling this a digital video system is selling it quite short, because it is phenomenally more feature rich than anything we've seen before from the likes of DJI, WalkSnail, HD0, OpenIPC. This system has way more capability than any of those. In this video, I'm going to be taking you through the physical specs of the system. We're going to be looking at how it works. We're going to be talking through the key features. We're going to be looking at the image quality that you get from the camera, the latency of the video link, and also the transmit power of the VTX as well. I'm going to be doing all the testing I can to figure out how this system works and to give you an idea of whether this system is going to be right for you. It's a lot to cover in one video. Let's not waste any more time. Let's dive right into it. If at any point during the video you decide the EDGE T3 video system is just too good value to pass up, then there are links down in the video description to where you can pick one up today. And they are affiliate links, which means that if you click on that link and make a purchase, it helps support the channel and it won't cost you a penny. So please do use those links if you possibly can. I wanted to start by showing you some flight footage from the system to give you an idea of how it performs in a typical FPV use case. Here, I'm just going to be flying relatively slowly, cruising around because I'm recording this through a cam link, and so the delay on my end while I'm recording this is pretty horrendous. So just going to be doing some light cruising, but this is still going to give you an idea of how the system handles faster moving footage like we have in FPV, how it deals with encoding the grass and the foliage that we're often flying close to or through, and also how it deals with the kind of varying bit rate that you get as you fly further away or fly closer to wherever you're standing. And overall, I think the system copes reasonably well with the detail. I don't think it's quite as good as DJI, certainly, and also not quite as good as WalkSnail Avatar. But we have to remember that this system is still in its very early days, and certainly the performance that I'm seeing is very reminiscent of what we used to see with the early versions of WalkSnail Avatar, and actually the early pre-release beta versions of the DJI V1 system as well, when you did get a lot of blocking, a lot of artifacting, a lot of smearing of the footage during fast-moving scenes before they had tuned the encoders to be able to kind of retain that detail even as the bitrate drops or even as the scene is moving very quickly. I'm also going to give you a bit of a side-by-side with the onboard recorded footage so you can see how the footage that you're going to see in your goggles compares to the footage that you're going to see when you look at the recording afterwards. And I think the onboard recorded footage obviously is not going to have any of the kind of compression or bitrate issues that you have with the over-the-air video link. But it also, this gives you an idea of what you're going to see when you compare the two. And also, of course, the OSD is not going to be present in the onboard footage. So now that you've had a chance to see what the flight footage looks like, it's time to talk about what makes this system new and different to what we've had before in digital FPV. One of the things that makes the EDGE T3 cool is that it operates more as like a general purpose IP radio than a dedicated video link. To explain what this means, I need to take you back a little bit and to look at how we have done radio communication with drones in the past. Let's start by looking at analog FPV. Here we have two completely independent radio links. There's a 5.8 gigahertz link from the analog VTX to the goggles, and that's one way. And then we have a bidirectional 2.4 gigahertz or 900 megahertz link between the receiver on the drone and your radio. And these two systems don't talk to each other. They're on different frequencies, different channels. And any sort of interaction or communication that goes on between the VTX and the radio has to go through the flight controller. If we move forward now to a digital system, now we have two bidirectional links, a 5.8 gigahertz link for the video and a 2.4 or 900 link for the receiver. And again, these two links don't talk to each other unless you're using something like the DJI system with the DJI controller, in which case your control link also goes through the same link as the goggles. there's no intercommunication. And again, we have the receiver and like maybe a GPS module talks to the flight controller, and then you get that information perhaps as telemetry over your radio link, or perhaps as the OSD in your goggles. But again, these are kind of two separate independent systems. If we look at what the EDGE T3 system does, it's a more general purpose IP radio, and so that opens up a whole heap more possibilities for what you can do. Basically, you're going to have some sort of network at the ground station end where you're standing, which might include your goggles, your radio, it might include a laptop with something like Mission Planner or a Q ground control on it. If you're using ArduPilot, it might have a wireless network component. The EDGE T3 supports wireless streaming of the video, so you might have a wireless screen. You could have your phone that's connected with, let's say, something like a future version of the Betaflight app, where you can adjust settings on the drone from your phone. All of that is connected to the VRX module here, and then that is then connected to the VTX module on your drone. And on the drone, you have kind of the same thing. You have a local network on your drone with loads of different devices connected to it. So you can have your flight controller connected, which might also be connected to the GPS, so you can get your GPS telemetry. You might have other things connected. So you might have like a gimbal camera or separate IP cameras, or even like a cinematography camera all hooked up. And again, that data can come back through this link and then go to the laptop or to your remote screen, anything like that. So in a sense, you have two networks connected by this EDGE T3 wireless link, and you can put anything you can think of that operates as like an Ethernet device. So it has an IP address, you have IP addresses at this end and IP addresses at this end, and any of the components can theoretically talk to each other over this link. And that opens up a whole lot more possibility for configuration, for having multiple people controlling the same drone, or multiple drones being controlled by one person. All of that's not really possible with this kind of separate links that we've got now, but is all totally possible with an IP radio link. For the avoidance of doubt, I don't think all of this functionality is available right now with this system, but the presence of an Ethernet port and Wi-Fi on the VRX and an Ethernet port on the VTX do strongly suggest that the hardware has the potential to do this type of networking. And for the functionality that is available right now, $279 is more than a fair price. Now let's look at the VTX on the bench. And we have an all aluminium CNC heat spreader top and bottom with M2 threaded holes, 20 by 20 on top and 25.5 by 25.5 on the bottom. The antennas are left-hand circularly polarized, and they're connected to the VTX by UFL connectors underneath this aluminium plate here with the 3 screws. The camera has the same mounting as the DJI O3 camera, so 2 M2 holes 6mm spaced, and this camera will fit in the AOS Evo and AOS V5 camera cages just like DJI O3, but the lens assembly protrudes a little bit more, so it does stick out a little bit further than DJI O3 in those frames. The camera supports ND filters with the same mounting as DJI O3, so you can use ND filters with this camera if you want to. Coming back to the features on the VTX, we have a micro SD card slot on one side, and this VTX came with a 32GB micro SD card, and it doesn't sit flush or subflush with the housing like the DJI VTX, but I do think this makes it easier to remove the micro SD card when the VTX is fitted into the drone, so I don't mind that too much. It is nice and secure when it's popped in, it's not going to come out. Next to the micro SD card slot is the bind button for the VTX. I got this VTX as a kit with the VRX module, and I did not need to bind this VTX. It just came bound. So you may not need to bind yours either, but if you buy the VTX separately, then you can bind it with this button. On the back of the VTX are 2 JST SH 1.0 plugs, a 4-pin plug, which is for Ethernet, for firmware updates, and I think there might be potential for like networking other devices to this VTX in the future. But for right now, it's for firmware updates. And we have a 6-pin plug, which is the standard DJI 6-pin connector. So we have power, ground, TX, RX, and an S-bus line as well. On the front of the VTX, we have another connector, which has pins for USB. So if you wanted an external USB port, not sure what you'd use that for this VTX, but those pins are broken out. And then you have connectors for servo motors for a 2-axis gimbal for the camera. So a pitch and yaw gimbal. So if you did want to use this camera with the gimbal, then there is a control plug already there for it. And that pretty much covers everything on the VTX. Now let's look at the EDGE T3 VRX module. And you can see that we have 2 left-hand circularly polarized patch antennas connected to 2 RP SMA connectors by these threaded adapters. On the right-hand side, we have a USB-C cable for video out, and you can use that either with a USB-C display or a USB-C to HDMI or mini HDMI cable to run a screen or goggles. We've got a JST SH 1.0 connector, 4-pin for this Ethernet adapter, which you can use for firmware updates, and I suspect networking other devices into this module, although there's no information about that. We also have this JST SH 1.0 connector, 6-pin for this cable, which comes with no documentation whatsoever. So no idea what this cable does. From the colors, it looks like it might be power and data, but not sure. Chris from the future here. I have been informed by EDGE that this port is for a radio controller and RC telemetry. No idea how you actually use that as of now, but potentially you could plug it into like an EDGE TX radio somehow, and then use the VRX module to send your control link to the VTX module. And then of course you have that S bus out on the VTX module to send the information to your flight controller. So hopefully EDGE are going to give us some more information in the future about exactly how to get this working. But if it does work, it means that you won't need a separate receiver on your drone. You can do all of your radio control through your VTX link. On the other side, we have a USB-C cable for charging the onboard 5000 milliamp hour 1S battery. And you can also take power from this port to power something like an external display, which will take the power from the internal battery while the VRX is operating. We have a bind button and a power button and 2 lights to indicate the binding status. The onboard battery is good for about 80 to 100 minutes of runtime. Obviously, if you're running a display off the battery at the same time, that's going to reduce that duration. But if you need longer than 80 to 100 minutes, you can, of course, power the device over this USB port while it's running using a USB power bank or power supply, and then you can run it forever. We have a little fan on the top for cooling everything. And yeah, that's pretty much everything for this VRX module. It's worth mentioning at this point that as well as getting video out over the USB-C port, you can also get video out over the Ethernet port by monitoring a URL with a video stream attached to it, which could be useful depending on what your use case is. Now we've been over the physical specs of the system, let's take it over to the bench and power it all up. Now that I have the system powered up on the bench, I wanted to take you through the menu. And this helps give you an idea of the capabilities of the system as well as the options that you get. So within the frequency select, we go into the 5 GHz band. We have options from 5.885 GHz all the way down to 5.18 GHz. And these are in about 20 megahertz steps, so similar to Wi-Fi channels. If we go back and look at the transmit power, you can see that we have a load of different transmit power settings depending on what band the VTX is operating at. So if we go into one of these, you can see that we have choices up to 2000 milliwatts transmit power and as low as 20 milliwatts. And we can just go through those settings and set a different setting for all of the different bands as well. If we go into the air unit menu, we can choose what cell type we're using on the drone, so lithium polymer or lithium ion. We can choose how many cells in series we have in the battery. And we have settings for the camera, so the electronic filters, the starlight setting for the Sony StarViz sensor, flicker compensation, the different color modes, and exposure compensation. All of those are available in this menu. We have settings for a remote control, so looking at stick modes, channel mappings. We can look at the channel values to see what they're all currently set to. Obviously 0 because I haven't got a remote control connected at the moment.
and also to do physical stick calibration as well. Clearly this system is meant to be used with some sort of remote, but obviously that's either not available or certainly I don't have it. If we go into the UI layout, we can choose all of the different UI elements that you see on the OSD, choose their position, choose the type and whether they're visible or not. We've got English and Chinese as the language options, and we can see the versions for the ground unit and the air unit. Country, currently unspecified, so I guess I'm operating from an undisclosed location, but I imagine in the fullness of time that will have settings for different countries to make the VTX compliant with different regions.
Now that we've looked at the physical specs of this system on the bench, it's time to take a look at the test results, and we're going to start with VTX Output Power. And this is actually quite difficult to measure because the VTX output power is really dynamic with this system. It moves up and down a lot more than I've seen with any other system from DJI or WalkSnail, for example. To show you what I mean, I've got a little clip of the power meter while I have the VTX set to maximum output, and I'm just going to walk away from it with the VRX. So the signal strength is going to drop down. And you can see as I walk further and further away, the power output from the VTX just steps up and up and up. To get the peak output power of the system, I took the VRX far enough away that it was down to, just barely hanging on in terms of signal strength. We were down at about 5 megabits per second, 1 bar, and if I'd have gone any further, the link would have dropped. Once I had the VRX that far away, I measured the output from the VTX on all the different channels, and overall, even with this method, the power still fluctuates up and down a little bit. So I took the peak value that I saw to kind of give an idea of what you can expect for the maximum possible output from the system. So with all that said, let's take a look at the results. So here are the results from the VTX power output testing. And what I did here was I measured the output from each of the 2 antennas separately, and then I added them together to get the total VTX output power. And I measured the output on 3 settings. So the 25 milliwatt setting, the 200 milliwatt setting, and the maximum power output setting, which was 2000 milliwatts. Now, of course, those are just the numbers in the menus. When we actually look at the VTX conducted output power, we can see that on the 25 milliwatt setting, we were only getting, less than 0.2 milliwatts of conducted output power total across the 2 antennas. At the 200 milliwatt setting, we were getting anywhere from about 0.7 milliwatts of conducted output to about 0.3 milliwatts of conducted output, again depending precisely on the frequency, and that is the total across both antennas. So each antenna was approximately half of that. On the maximum power output setting, which is supposedly 2000 milliwatts, I was getting anywhere from 80 milliwatts of conducted output to as much as 400 milliwatts of conducted output depending on the channel, and it's not very consistent across the frequencies, let's put it that way. We're getting quite a big range of output power, a factor of, at least 4 across the different channels. So I think there's probably some scope here to tune the power amplifiers a bit more. There's also certainly some scope for me to try and improve the way that I'm measuring the conducted output power of this type of system. But the maximum output seemed to pretty consistently come out at 5.3 gigahertz and about 5.75 gigahertz on that highest 2000 milliwatt setting. So of course the numbers don't tell the whole story, and I want to give you a kind of qualitative assessment of the range and penetration of the system. As I was walking the VRX away from the VTX and checking the bitrate, I felt like the bitrate that was being reported was pretty similar to the bitrate achieved with something like the WalkSnail system or DJI O3 at the same distance from the VTX. So we're getting kind of equivalent bitrate to range as you'd get from something like the WalkSnail or DJI systems. At the extreme edge of range, one of the things I did notice was that although the link does drop, it drops in about the same place as DJI or WalkSnail, and the link recovers really, really quickly when you come back inside that extreme edge of range. And it recovers, I think, a little bit faster qualitatively than certainly the WalkSnail system, and maybe as fast or maybe even a little bit faster than DJI. So that's really nice behavior to see. It's really good to see the link recovering nice and quickly when you come back within range. And it recovers even at a very low bit rate. So it will sort of drop at 5 megabits per second, And the moment you sort of get back within that sort of 5, 6, 7 megabits per second range, the link recovers even at that very low bit rate, which is not what we see with some other systems. Now let's talk about image quality. And for this, we're going to do a side-by-side test with the Walksnail Moonlight 4K kit. Now, bear in mind that the Walksnail kit is about $60 more than the EDGE T3 VTX. So although it does have a low light sensor and onboard recording, same as the EDGE T3, it is quite a bit more expensive. Nonetheless, we're going to look at these two side by side, and this is going to be in daylight. And I'm not going to tell you which camera is which to begin with. So take a look at the images, decide which one you prefer, and after a few seconds, I'm going to show you which one is which. Both of these cameras are recording in 1080p 60, just to make it a fair comparison. But overall, I think we can see that the Walksnail Moonlight 4K kit is doing a bit of a better job with the dynamic range, the colors, the detail in the foliage, all of that sort of stuff. And the EDGE T3 is producing a perfectly serviceable image. It's quite a nice, bright image, but it's not got quite the same amount of detail and not the same amount of dynamic range as what we get from the Walksnail camera. This is, of course, with the default settings, and there are various color and other settings that you can play with for the EDGE T3 camera and for the Walksnail camera as well, but this is just as they are by default. One of the things I noticed whilst doing this image quality testing is that the EDGE T3 VTX is really very resistant to overheating. I left it just sitting on the bench, powered up, recording 1080p 60 for 2 or 3, 4 minutes, and it didn't even heat up appreciably. I mean, it got up to about 50 or 60 degrees. Compare that to the Walksnail Moonlight 4K kit, which will overheat to well over 110 degrees centigrade in just a minute or two of being powered on, especially if you're recording video. Clearly, EDGE are doing something right with the power management of this VTX or the chipset that they're using, because it is able to stay nice and cool even whilst recording and just sitting on the bench with no airflow. Now that we've looked at VTX output power and image quality, it's time to talk about video link latency. And for that, we're going to be connecting the EDGE T3 through a USB-C to mini HDMI cable into the HDMI input of my HD0 goggles. Now, I know from my testing and HD0 specs that the HDMI input latency of these goggles is less than 1 millisecond. So if we take the image out of the VRX, send it straight to the goggles, and then do a glass-to-glass latency measurement, that really is an absolute best case for how quickly you can get an image from the camera to the screen of your goggles or an external screen. So with this hooked up, we're going to be using my standard glass-to-glass latency measurement, where we have 2 LEDs, one in the goggles and one pointed at the camera. We turn them both on at exactly the same moment, and then we measure the latency from when we see the LED turn on next to the goggle screen to when we see the lit LED in the screen of the goggles itself. Let me show you the latency results now. Here we're looking at the raw data from 4 latency tests recorded at 1000 frames per second. At time equals 0, the LED turns on both in front of the camera and in the goggles. And now we're just counting frames or counting milliseconds until the light from the LED in front of the camera makes an impression on the screen of the goggles. And we're looking for that first bright line of pixels that indicates the pipeline latency of the whole system. Because I've done 4 tests, you'll be able to see that not only does the time to first bright pixel take about 65 milliseconds in the best case, but also it takes a different amount of time for the 4 tests, showing that the system has a variable latency as well. I ran 10 different latency tests on this system, all under ideal conditions, and I got a pipeline latency of anywhere from 61 to 75 milliseconds at a frame rate of 60 frames per second. If we compare the latency of the EDGE T3 system to competitor FPV systems, we can see that EDGE still have quite a long way to go to match DJI 04 at the same frame rate. DJI 04 is about 20 milliseconds faster, and even further to go to match DJI 04 race mode at 100 frames per second, Walksnail Avatar at 100 frames per second, or HD0 at either 90 or 60 frames per second. What this means is that the EDGE T3 isn't really suitable for racing, and it isn't really suitable for fast, dynamic freestyle flying in close proximity to objects. There's just too much delay between what the camera sees and what your goggle screens are showing you. However, if you prefer long-range flying, slow and gentle cruising, or you want to do more autonomous flying like with Arduino, then a latency of 65 milliseconds isn't really going to bother you at all, and the EDGE T3 is going to be a perfectly good system for that, especially given that the image quality is perfectly good enough. Now that I've done all of my testing, and before I leave you with some flight footage, all that remains is for me to give you my thoughts on this new EDGE T3 video system. And let's start with the positives. The feature set of this video system, for the price of $119 for the VTX and $160 for the VRX, is really exceptional. Obviously, you've got a nice high quality digital video link. The image quality of that is really quite nice. And it also supports onboard recording, OSD. It supports MAVLink telemetry. So if you're flying ArduPilot, you can have that link back to your laptop to do control of the drone over MAVLink using this system, which is really, really great and something that is not offered by any other digital video system for FPV drones right now. We have the potential to have a radio link through the system. Although I'm not quite sure how that works as of yet, but maybe that's potential for the future. And you also have potential for video monitoring over Ethernet and potentially the option to have Ethernet connectivity through the video link in the future as well. Obviously that's potential. That feature set is far and away above anything you get with any other digital video system for FPV right now. And it's a feature set that's more comparable to what you would see with like commercial systems for autonomous drones like HereLink and stuff like that. So for $279, it is fantastic value on that front. In terms of the cons, or perhaps the things to be aware of, the video link latency of 65 milliseconds, time to first bright pixel, means that the link is not really suitable for racing or fast dynamic freestyle flying. For that, you're still going to want to look to DJI O4 race mode, Walks Now Avatar, or HD0 90 FPS to get the absolute lowest possible latency. But if you're flying long range, you're cruising, you're flying in a more relaxed way, then probably 65 milliseconds is not going to be a deal breaker for you, and you may find that the value and the feature set of the EDGE T3 is going to just push it over the top. In terms of flexibility, the fact that you can use any goggles or any screen with the system is really nice. The fact that the VRX is battery powered, so you don't need a separate battery and can even drive the screen, is another nice feature. So there's a lot to like about it. And I think that if this is the way that FPV VTXs are going in the future, and we can get the latency down to closer to what we're getting from DJI O4 in race mode today, whilst keeping all of these cool other features which support ArduPilot, which support perhaps doing more with the link than just video, so we can do radio control, telemetry, and all of that good stuff, then I think that represents a really nice step forward with the technology, and I can definitely see that being just like a quality of life improvement for FPV pilots in the future. If after considering all this information, you've decided that you'd like to try an EDGE T3 VTX and VRX kit for yourself, then there are links down in the video description to where you can pick one up today. And they are affiliate links, which means that if you click through on that link, it won't cost you any more money, but you will help support the channel because the retailer will give me a small commission as a thank you for sending you their way. So please do use those links if you possibly can and help me make more videos like this for all of you guys in the future. That's all I have for you for today. So until next time, I wish you all very happy flying and enjoy this flight footage.
Every time we raise the heat, farther, faster, higher, stronger. What seemed impossible to beat, someone is bound to make it look easy. From